Well, hello internet, and this is Eric. I want to make a video response for the Veritasium bullet block experiment, and I'm going to show you um, some. I'm going to first start with some of the video responses that I have watched and felt that it was actually wrong, that their response was wrong, and there's a couple of video responses that I want to tell you about. The first one is that the block actually did actually go lower, but it is too little to be seen by human eyes. Um, so, well, the explanation was that the energy it takes to spin the block is only required at the initial impact, and it doesn't take energy to maintain the rotation of the block. Well, that's true. It only requires at the beginning, but it does take actually a quite a significant amount of energy to spin the block. um, and if you actually do the calculation, the amount of energy it takes to spin the block is about 50% of the gravitational potential energy of the block when the block reached its maximum height. So what I'm saying is that if you actually converted all of its rotational energy into a gravitational potential energy, you will actually have a block going to a height of 1.5 times the height that it actually went to. The second argument that some people made was that, well, Veritasium must be tricking us. He might be using different bullet, different rifle. Um, um, like it's maybe he just put some different block or whatever. The beauty about science is that other people can repeat the experiment and they can find out if their experiment actually matches with the Veritasium video response. And then I didn't actually try it myself, of course, but because I don't have a rifle, but I have no doubt that Veritasium didn't trick us. Okay, so this time I'm going to actually explain you how I think the block actually went to the same height. Well, the block may have went to a different height, but it's nothing like what you think it is. The rotation of the block may have caused a little bit of air friction, which can be neglected. Actually went to a slightly lower height, but I'm going to ignore that in this video. Okay, so let's say the bullet hit the block, and then it penetrated. Let's say the block is about 10 centimeter, and then let's say the bullet at the center of the block actually traveled to 8 centimeter. This is just purely guess, but it doesn't really matter. Then the bullet has traveled 8 centimeter within the block, and then the amount of friction and the sound energy really depends on the distance the bullet has traveled inside the block. The longer distance it travels inside the block, the more friction and more heat energy it generates, and more sound energy it generates. So I believe that the bullet actually penetrated deeper in the center of the block than on the side. And then the reason is that when you hit the center of the block, you're transferring all of the bullet's momentum into the block really quickly, because the block is lifting up entirely. So in order to lift up, let's say 3 centimeter of the block at the center, you have to lift up the entire block 3 centimeter. But if you hit the side of the block, um, and let's say you want to lift up 3 centimeter. Well, you're not lifting up the entire block of the for 3 centimeter. You're actually lifting up the corner of it. And that means that it has to lift up much lower block, and I'm guessing it's about 50% of the mass. Okay, so I'm going to actually show you why it penetrates lower. So here, the bullet travel a centimeter, but then if you draw a straight line, the bullet here actually travel, let's say 2 centimeter or something like that. So the bullet actually penetrates much lower, and the amount of heat and friction and sound energy is much lower on the second block. And the reason is because the time it takes for the bullet to transfer all of its momentum to the block is much longer. So it is effectively transferring all of its momentum rather than wasting its momentum into heat and sound energy. Alright, I hope that clears some of the confusion and hopefully solved some of the mystery that Veritasium has inspired on you. And science, go, go, go!